This is going to work, right, Petra? We actually tested this. Oh, come on, come on. Oh, jeez. Here we go. Hope for the best. All right, we'll just go to this one. That's okay. So well, first of all, I'd like to thank Sam for his little insight at the beginning there that it's like being a professor up here, except it's a big difference, Sam, with you, because now the room is full, people are awake, and they're happy. So it's very different. There we go. Okay. Let's see. Got, it does take a little time to set up. I apologize for that. And let's see. We'll go here. And got that. And let's see. There we go. Good. All right. We'll put that over there. Great. And let's see. Okay. There. All right. Let's see. One more thing I need. Oh, and Sophie, could you sometime talk to my kids about how to properly address their father? I love that Dr. Daddy thing. I got one more thing to get here. Okay. All right, so my presentation isn't quite as involved as the previous ones. CSI AK is the title of my presentation, and CSI, of course, stands for Capacitive Substance Identification. So what we've got here, we've seen magnetic field, you've seen capacitance with Professor Bitar. In 2019, we did a little level detector, a capacitive level detector. You can see I've got a cup here with 2 strips of copper down the side, 2 wires coming off of that. And as you fill it up with water, the electric field lines from the 2 electrodes go through the water, and it changes the capacitance. You can measure the capacitance with an RC circuit or lots of different ways. And people in 2019 seem to think it was a pretty interesting thing. But that's only because they haven't seen all the great stuff in 4902 yet. Oh, and I got it. Where's Professor Bitar? What just happened here reminded me of when I started here in 1994. Professor Bitar was getting his master's degree at the time, and he was right in my class. And he was also teaching I think he was teaching Micro 1 at the time, right? So there was a guy, remember Howard? How could you forget Howard? It was great. Howard was sitting, he was one of these guys that sat right in the front row, and he always had questions. He was always raising his hand. Great guy. And I said, now, is there anyone here who hasn't seen small signal analysis? Howard raises his hand. Well, Professor Bitar was sitting right behind him, and he like rolled up his notes and said, you have seen it in the class I just taught. It was great. It was great. So, and then the other thing I always think of in this room, I had another student like Howard who always sat in the back row. There's a class of like 20 people in AK 116, and he's sitting way in the back row all the time. But he was the smartest kid in the class. So I'm lecturing something, and by the end of the lecture, nobody else is answering any questions. He's just sitting in the back row raising his hand every time. So I ask something, he does this. I say, let's not see the same hands every time. So he does this. So I start cracking up, but no one else can see him because he's in the back row. So that's what it's like. So anyway, so in 2019, I thought, it's nice to have this little cup thing, for a demo in a class, but for the Spark Party, we should scale it up. and put a little mystery into it. So, so what we've got here is some buckets with different substances in them that have different dielectric constants. And we're going to see if we can make some measurements and identify what those substances are. So we're going to look at the concept of capacitance, the concept of resonance, audio down conversion through some digital circuitry, so I can just prove that digital is a special case of analog, and a demo, of course. So can we detect different materials through their dielectric constants? Well, the concept of capacitance, epsilon naught A over D. A is the area, D is the distance between the plates. For all these buckets, it's the same. I've got these two capacitive plates on the outside. I'm just going to clip on there with the alligator clips, and then it's going to a circuit that's going to measure the capacitance somehow. Epsilon naught, the permittivity of free space. And if I put something in there, the relative dielectric constant is going to multiply that because the field lines are now going through a material. So the relative E sub r is going to scale the capacitance. And of course, the displacement current, if we fully analyze that, well, we don't need to, and those double integrals scare me. Is Professor Ludwig here? Well, now I can say anything I want, I guess, but let's just get rid of that. All right, so the idea of resonance. Resonance, we've got two energy storage modes in a system, the magnetic field in the inductor, the electric field in the capacitor. Sort of like a swing, the way energy gets traded back and forth between potential and kinetic energy. And it's got a natural frequency that it wants to oscillate at, and that's proportional to 1 over the square root of LC. So we've got an LC oscillator here, and we're going to use that, and as the frequency changes, we'll see it on the oscilloscope, we'll hear it, and we'll be able to see the difference between these different materials. And the issue is we want to get down to audio frequencies, but the values of the inductor and the capacitor that we have are going to make it too high a frequency. So we've got to do something about that. So let's get right on to how we solve that problem. Okay, the Barkhausen criteria. I didn't actually make up these slides, and somebody else did. I won't say who they are, Jeff and Petra, but they were really into the Barkhausen criteria, and I said, we don't need that. It's too complicated for the Spark Party. Don't put it in there. But I guess they insisted on one slide. So if we have a feedback loop and the gain is 1 around the loop, then it's going to oscillate. Okay, so they got their one slide of Barkhausen. Great. Okay. All right, so this is Barkhausen, all right? He's got a criteria named after him. He doesn't have a unit named after him. I always wanted to have a unit named after me. And people who've had class with me know that. If there was a unit for procrastination, that would be me. I should have done the homework, but I waited 2 McNeils, and now that would be the unit I had. All right. So you got your 2 slides on Barkhausen, okay? Great. Oh. All right, so there's a better demo with the Barkhausen effect. Okay, you got your 3 slides on Barkhausen. All right. Audio down conversion, finally. So the problem is that this is going to oscillate at hundreds of kilohertz or even megahertz, which is out of the range of human hearing. So we've got to do some down conversion. And the way we're going to do it is actually with a digital technique, dividing down to within the frequency range of 20 hertz to 20 kilohertz. And we're going to use this with flip-flops inside a counter. And it's really a very simple circuit here, as you can see. But if we just ignore all that, it should work just fine. All right, so let's go to the demo. You can see over here the picture of the waveform. And let's see. Well, I'll just do auto set like everyone else does. There it is. Okay. So there we are. And if I think the frequency was actually too high before with the dielectric constant of 1 with nitrogen, which is mostly what air is. Here I've got sand, you can see in here, which is silicon dioxide. It's got a relative dielectric constant of about 4. And if you listen to this, There we go. So there's hear that tone. See if you can remember that. And now I've got water here. Let's see, we've got water there. So we'll clip on there. Really should have a grad student to do this heavy lifting. Okay. All right, so how do I clip on? Okay, so there's that. Clip onto this. All right. And let's see, can we hear that? Oh, come on. Now it's too low to hear. Give me a break. Am I not on? Oh, jeez. Did it go? See, you know, they showed me this oscillator circuit. They got it off this Wikipedia thing. And I said, you know, I don't really understand this. I don't feel comfortable. It's not going to work. Oh, jeez. We got the power on. Come on. Come on. That's the thing. Between oscillators and amplifiers, they do. Boy. All right, we'll do this next year, and I'll have you know what? I'll have Professor Batar do it, and then it'll work. All right. Well, let's see. So, oh, there it goes. All right. Let's see if we can hear that. Oh. Come on. Oh. Jeez. Let's see. Oh. Yeah, take my shoes out. Okay. No, you know what? It happens every time. It worked just fine when we did it before. Try one. Oh, geez. That's all right. You know what? Oh, there. Oh, jeez. I don't know if I can just. No. That's all right. This last material that I have does have a different dielectric content. It's a little volatile, but there's really nothing to worry about. And you can tell from the sound it makes what it's going to be. Let's get on there. Hold on a second. Let's do that there. Oh, there we go. Okay, and let me just clip on there. Ah, jeez. Boy, I should. This one, yeah, I didn't. Hold on. Okay, so let's just. Now. Jeez, you know what? I mean, if you want to know what it is, just look into it. That concludes my presentation.
Professor McNeil has given me an absolutely impossible act to follow. The only possible thing I could think of is money. So, several years ago, the IEEE PES, who knows what PES means? Let's shout it out.
Power and Energy Society.
Power, it used to stand for Power Engineering Society, but they wanted to broaden out, and so now it means Power and Energy Society. Decided, with good reason, that there were not enough electric power engineers being graduated. And so what is one way, not necessarily the best way, but one way to attract people into a given area, that being money, scholarships. So they have solicited corporations, utilities like National Grid, corporations like GE, Schneider Electric, Noble Engineering is one of the big consulting companies, generated quite a lot of money for scholarships nationwide, and now I believe they're going worldwide. This is the third year that that program has been in existence. Dr. Uzanovic, who, as I said, got stuck in traffic in Connecticut, isn't here, is the chairwoman, I guess, chairperson of the Region 1 area. Region 1 is the New England northeast part of the IEEE. I serve on the committee, but the fact that she, who is a professor in our master's level power engineering program, and I are on the committee has nothing to do with the fact that in each of the 3 years, we at WPI have received the largest number of scholarships in the Northeast. It's because we have great students, and certainly I don't review any of our own students. Those are handled by other faculty and industry people around the Northeast. So we have 7 scholarships that were just awarded. They have been announced, so you know who you are. There's not going to be any surprises tonight, but most of the people are here, and we would like to give them their certificates and recognize them. And first is Ali Akhtar. Ali. Congratulations. Here you go. Some of these people are for their second or third year. Some are the first year of scholarship. They are available to students beginning in their first year. So we'd like them to stay active in electric power engineering. We provide internships in the summer to really get them involved. Next is Jeremy Jaguar. Jeremy. Congratulations, Jeremy. There you go. Jordan Rumble. Congratulations, Jordan. Greg Sharp. Congratulations, Greg.
Thank you.
Chris Sontag. Congratulations, Chris. There you go. Patrick Sullivan. Pat, congratulations. Thank you. There you go. And last but certainly not least, Julia Trum. Yes. Congratulations, Julia. And before you leave, before people start talking, because I think intermission is next, if I can get all the winners down here, we'll try to save some dessert for you and take a quick photograph. And so everybody come down here, and I think we're intermission now. Is that correct? So come back after you get some dessert.